Okay, in this video, we're talking about percent yield. So as soon as we hear percent, I see the percent symbol and I know that I'm going to have to times it by 100 to make it a percent. So yield's just what we're talking about in our chemical reactions. Yield just means that we're looking at how much did we yield in this chemical reaction. So it also lets us know how well we did in the lab. It takes what you actually got in lab and it compares to what you calculated on paper, aka your theoretical for it. So the formula for percent yield is the actual from lab, and then we're taking the theoretical from paper, and then we times it by 100 to let us know how we did. Now in lab, you can actually have more product than you were supposed to make because of contamination, or maybe one of the reactants didn't complete for it. So you can actually have higher than 100%. We want exactly 100% because we want our reactants to be conserved, aka equal to our products, but it doesn't always happen like that. And a lot of times we'll see in lab that we're actually less than 100%, sometimes even less than 50%, but it lets us know how well. Our goal is to be around 50% when we're doing a lab experiment. So let's take a look at this chart. It says for this methane combustion reaction, we're going to be having 25 grams of my first reactant and 25 grams of my second. Now, theoretically, methane can make 56.2 grams of water, and theoretically, oxygen can make 14.1 grams. So remember, when we're looking for our limiting and excess reactants, we're looking at the theoretical. So this theoretical just means that you've done the math and you figured out that if you go from grams of CH4 to grams of water, you're going to see that you make 56.2 grams. The bottom part is if you had 25 grams of oxygen, you're going to make 14.1 grams of water. So we actually use this part of our table to decide which is our limiting and which is our excess. So we look back, remember that our limiting is going to be our lower, and number one, our excess is going to be the higher one. So we notice that 56.2 is higher, so our excess would be CH4, and we would notice that O2 is our lower, that would be our limiter. Now it says, what is the percent yield for this? So remember, we have to do our actual, which is going to be our final tab. So we're going to do 13.5 over, well, which theoretical do you use? The one that limits it as your lower or the one that's higher as your excess? Well, we're going to use the one that's lower that limits it. So we're going to do 13.5 divided by 14.1 times 100. So we need our calculator ready to go for it. So 13.5 divided by 14.1. So we get our decimal, then we're going to times it by 100. So we're going to round it to our nearest whole percent. So we have 95.7446885 nearest percent. So will 7 round 5 up? Yes. So we're going to have a 96% yield, which is actually a really great job for this problem, because that means that 96% of your reactant was made into the expected product. And remember, we want to be at 100% that our mass was conserved. So I am going to erase the screen so you can see the answer pop up for this one. Okay, so now let's try our second example. You might want to pause the video and try it on your own for this single replacement reaction. Okay, welcome back. Hopefully you did pause it, and you would see that 15 grams of the first reactant would make 29.7 grams, and 15 grams of our second reactant was able to make 3.88 grams. Now we don't need the actual yet, so remember excess is going to be the higher. So which one's higher, 29.7 or 3.88? Good. The higher one is 29.7, so we would see the excess reactant is F2, and then we would see the limiter is the lower one, so that would be FeFi3. So when we look at our limiting and excess, if we look at the theoretical yield, they've already gone through the 4 steps to find that answer. So now that we've identified our excess and limiting, we have to do our percent yield. So this is where we're going to need our actual, And then we need our theoretical. Remember, the theoretical is the limiting theoretical. So we won't use 29.7 because that's the excess. We're going to use 3.88 for it. And then to make it into a percent, we're going to times it by 100. So hopefully you have your calculator out and ready to go for it. So we're going to do 2.50 divided by 3.88. We get our decimal, and then we times it by 100. So notice that we get 64.4329, 298969. And then we're going to round to the nearest whole percent. Will 4 round 4 up? Nope. So we're going to get 64%. Now, it wasn't as good as the 96% of above, but it wasn't bad. It just means that your reactant made 64% of the projected product it would. So it's a little bit lower. Maybe we lost something, there was a contamination, or we mismeasured when we did it for it. So that takes us through the basics of a percent yield problem. Thanks for watching.